Mm. Good evening to one and all. Myself, KV Ashok. Uh, I'm working as a faculty. Uh, so today, I would like to give some introduction about the subject computer organization. Okay, so in that subject, I'm going to discuss about some of the basic points regarding just what is a computer and what are the different functional units of the computer and how do they interact with each other. Okay, so these are the points I am going to discuss. Okay, so let's start our lecture. Okay, so first of all, before going to discuss about the computer organization, first of all, I would like to define what is a computer. Okay, so the computer, what is a computer actually? So computer, it is a programmable electronic device. Okay, it's a programmable electronic device designed to accept some data. So that means it is going to accept some data from the external environment, like so that means like from the external devices. So that means the devices that are attached to the computer. Okay, so it will accept some data. The device can be either an input device or the output device. Okay, so after accepting the data, so it is going to perform some prescribed mathematical and logical operations. Okay, so when we give some data as an input, okay, now so the computer will take the data and it is going to perform mathematical and logical operations on the data at a high speed, and display the results of these operations. Okay, so once again I am repeating. So a computer is a programmable electronic device which is designed to accept some data and perform some calculations like mathematical and logical operations at high speed and display the result of these operations. Okay, now I think you get some point. Okay. So regarding the definition of the computer, now let's quick start with the functional. What are the various functional units of the computer? Okay. So if you take any computer, okay, so it can be either a laptop or it can be a desktop or it can be a workstation, whatever it may be the computer. So any computer has three major components. Any computer has three major components. First one is the processor. Second one, memory. And third one, IO. Processor, memory, and IO. Okay. So any computer has three major components: processor, memory, and IO. Now, these three major components are connected through a bus that is called system bus. A bus that is called system bus. Now, if you see the functional units of the computer, okay, so this is nothing but what? IO, and this is nothing but the processor, and this is nothing but the processor, and this is nothing but the memory. Okay now, so processor, memory, and IO. So these three are interconnected by using the interconnection network. Okay, so that interconnection network is called the system bus. Okay now, so system bus is a bus which connects the major components of the computer. Okay, so system bus is a combination of three different buses. Okay now, first one is the address bus, second one data bus, and third one control bus. Address bus, data bus, and control. So we will discuss what do you mean by address bus, data bus, and control bus later in this section. Okay, now let's quick start with our okay, the major components, or you can call it as a functional units. Okay, now first one, input unit. Okay now, so input, so the name indicates itself, so which we are, so input is nothing but what, which we are giving. So that means we are giving something, we are giving something. So that means this unit accepts the coded information from human operators, okay now, using devices. So that means we are entering, so we are giving some information as an input to the computer using the input devices. Okay now let us take an example. Okay now, like a keyboard. Okay, so keyboard is there. So on the keyboard we are having some different keys. Okay, so every key on the keyboard is represented by one value that is called ASCII value. Suppose whenever you press key A on the keyboard, So that key A, you are giving it as an input. Okay, now, so that A has to be is having ASCII value. So the ASCII value of A is 65 in decimal. Okay, now this 65 has to be converted into zeros and ones. Okay, now, so that information is taken by the processor. Okay, now, and the processor gives the output to the external world, that is called output unit. We will discuss it later. Next one, memory unit. Okay, now what do you mean by the memory? So memory refers to the physical devices used to store programs or data. Now here, so there is a general definition of memory. Okay, so that definition is memory is nothing but the storage space. Memory is nothing but the storage space, or you can say memory is nothing but an array of locations where every location is identified with an address and every location contains some data. So if you take a general example, suppose if you want to find a house in a street, okay, so first of all, you should know the location of the house. How do you find the location of the house? By taking the reference as a like door number. Okay, so door number refers to nothing but what here, address. Okay, so when you know the door number, then immediately you can know the address, location of that house. Okay, like here also memory is nothing but was what is nothing what is memory. So memory refers to the physical devices used to store programs or data on the temporary or permanent basis for the use of a computer or other digital electronic device. Okay, so the memory consists of, okay, the memory consists of large number of semiconductor storage cells, like here flip-flops. Okay, so what is a flip-flop? You know very well. A flip-flop is a memory device which is capable of storing one bit of information. Okay, so here each semiconductor cell is capable of storing one bit of information, and these cells are rarely read or written individually. Instead, they are handled in groups of fixed size called words. Okay, so that means a word is nothing but I can call a word as a group of 16 bits. So a group of 8 bits is nothing but byte. Okay, so like double word is nothing but 32 bit, and multiple word which is nothing but 64 bit. So the memory is organized, okay, so that one word can be stored or retrieved in one basic operation. So the two basic operations that the CPU can perform is read and write operations. Now, what do you mean by read operation and what do you mean by write operation? Suppose if the processor wants to get some data from the memory, okay, so it is going to perform which operation? Read operation. Okay. Suppose if the processor has something which is to be sent to the memory, then it is going to perform write operation. So read is nothing but what? Receiving the data from the memory by the CPU, and write is nothing but sending the data to the memory by the CPU. Simple. Okay. So this is about memory unit. Memory is nothing but what? Storage space. Okay. Next one, output unit. Okay, so what is an output unit? The output unit, you know very well. Okay, so the output unit is the counterpart of the input unit. Okay, now, so which performs exactly opposite to the input unit, and its function is to send the processed results to the outside world. Okay, now, so that means, so after processing is done by the processor, okay, so it is going to send the display the result to the outside world. So that means whatever may be the process result, okay, so that should be sent to the outside world, okay, by using the output unit. Okay, so simple examples are, you know very well, the monitor which displays whatever may be the operation that can be performed by the CPU, so that will be displayed by the monitor. And printer, okay, which prints some characters like speakers, etc. So these are the examples of the output devices, or simply you can call it as a output unit. Okay, next one, ALU. ALU is nothing but arithmetic and logic unit. Okay, so this is one of the important part. Okay, so in the first diagram you have seen in the functional units. Okay, so there is a processor here. Okay, so the processor is having two units. First one is the arithmetic and logic unit, and second one is the control unit. Okay, now we are going to discuss about uh, arithmetic and logic unit. Okay, so the name indicates itself, it is going to perform arithmetic and logical operations. Okay, now, so what are the examples of the arithmetic operations? So, like addition, subtraction, multiplication, and division. Okay. Logical operations are nothing but AND operation, logical AND operation, logical OR, logical NOT. Okay. So, these are the basic logic operations. Next, NAND, NOR, XOR, and XNOR. Okay. So, these are nothing but the logical operations. So, the ALU can perform whether addition operation, like arithmetic operation, or it can perform the logical operation like the addition of two numbers. Now if you see here, addition of two numbers. Okay, so if two numbers located in the memory are to be added, so initially they are in the memory, so first we need to bring that operands from memory to the processor, and the addition is carried out by the ALU, and the sum may be then stored in the memory or retained in the processor for the immediate use. So that means immediately after performing the operation, the result can be either stored in the memory or it can be stored in the register. Okay. Next one, control unit. Now this is the most important unit. Okay. So ALU is going to perform, okay, which can be an arithmetic operation or logical operation. But what type of operation does the ALU perform? That will be decided by the control unit. Okay. So control unit, like if I say one example, okay, like control unit, if you take follow an analogy like that, director and hero. Okay, now whatever may be the director tells, hero will do that one. Okay, so here director is the control unit and hero is the arithmetic and logic unit. So the main purpose of the control unit is it is going to coordinate the operation of memory comma arithmetic and logic and IO units. Okay, mainly it is going to coordinate these units, and there are some control circuits. Okay, now so these are responsible for generating the timing signals, which signals, timing signals that govern the transfers and determine when a given action is to take place, at what time a particular action is to be carried out. So that will be decided by the control unit. So there are control circuits. So these circuits are responsible for the generation of the timing signals. Okay, now operation of the computer, just I will describe. Okay, so the computer accepts the information, okay, now in the form of programs and data through an input unit and stores it in the memory. Okay, so information stored in the memory is fetched under the program control into the arithmetic and logic unit where it is processed. Okay, so initially it fetches the data through an input unit and store that data into the memory. So whatever may be in the second step, the information which is stored in the memory is fetched under the program control. So that means the CPU takes the instruction from the memory and it is going to perform an operation. Okay, so that operation is done by the ALU. Okay, so whatever may be the processed after processing or after performing an operation, you will get some result. So the processing information leaves the computer through an output unit. Okay, so all the activities in the computer are directed by the control unit. So get the data to an input device and store it in memory, retrieve the data from the memory by the CPU, and it will process the data. Once again I am telling, okay, and the processed information leaves the computer through an output unit, and these whatever may be the activities that are performing, all the activities are directed by the control unit. Mm. So that's all I want to explain today. Okay. Mm. Thank you one and all.